Hello and welcome to our overview of describing common TCP/IP based attacks. The first thing for us to understand before we even get into these style of attacks is that this is based upon the TCP/IP protocol suite, also known as the IP protocol suite. So with so many operating systems and applications being based on this suite, when there is a vulnerability found within inside of the protocol suite, quite a bit of targets and their applications are going to be vulnerable to those attacks based upon those discoveries. Now, the next thing we need to understand as we move forward is any use of legacy deployments of this protocol stack, again, the TCP/IP or just called the IP protocol stack, is absolutely going to leave an application, leave an organization vulnerable. So this protocol suite has been around for a very, very long time, defined in a very, very early RFC or request for comment. And again, any uses of the older or even original protocol stack is certainly frowned against simply because of the initial deployment and known vulnerabilities. As we review IP vulnerabilities, keep in mind that this is at layer 3 of the OSI model. It is the protocol over which all of the other protocols within the TCP/IP stack travel. So a vulnerability or a style of attack for IP is going to impact quite a bit of the other protocols. So as a high-level overview of some of the vulnerabilities, for example, man-in-the-middle attack, using a man-in-the-middle attack by way of or to execute session hijacking, claiming to be from a source that you're not really from, or what is referred to as an IP address spoofing, or in the case of a DOS or DDoS, distributed denial of service, or just a denial of service attack, the process of consuming available resources, CPU, memory, networking, and storage of a destination with illegitimate, invalid sessions. Also, there are no more resources available to service valid sessions. And that, by the way, also kind of encapsulates our last example here with resource exhaustion attacks, whether it again be to a single system in a DOS attack, as we mentioned a moment ago, or from multiple systems in the case of a distributed denial of service. But again, these are all used to launch a form of a DOS attack, which is again a resource exhaustion attack. Our next review here is going to be on ICMP vulnerabilities or Internet Control Messaging Protocol. Before we get into this, please understand that ICMP works on protocol types or protocol options, and various different messages or various different uses of ICMP will be based upon the protocol type that is used between the source and the destination. Now, with that being out there being understood, please keep in mind that there are many, many different ICMP message types that, number one, exist, period. And then number two, that we don't even use anymore. And then number three, ICMP message types that can be used against us in a manner that we were not even originally intending. So again, three different categories, if you will, or things to keep in mind when thinking about the way ICMP works. So for example, one of the ICMP message types that can be used against us might be an ICMP unreachable that are used by attackers to just discover a network or again, perform reconnaissance. Maybe while the attacker is trying to perform reconnaissance, they want to understand, hey, I have the IP address, but I need to know your mask. So maybe I can better understand, I can better discover your subnet and the systems around you. So ICMP mask replies can be used in that manner. ICMP redirects where we were intending to go through this device or communicate in this direction, but especially used in a man-in-the-middle attack, ICMP redirects could be used to send information in a direction that was not originally intended from the source in the chain of communication. ICMP router discovery, as its name says, used to discover any layer 3 host that are used by the end devices as gateways. So now we can, if we were to turn to a life of crime as an attacker, start discovering your network. And then firewalk. I think the key word here for me when I first learned this term was walking. identifying available addresses on a network, and then walking through well-known port numbers and then maybe even a larger range of port numbers to see, number one, what ports are open through an access list on a firewall, and then maybe even what ports are open on destination devices, and then what services are open on those destination devices. Continuing with the concept of ICMP vulnerabilities would be two more. ICMP tunneling, also known as ICMP TX, the TX again abbreviating the tunneling or the transmission, used as the term tunneling often is to establish a secretive or covert communication channel inside of which, again, these being ICMP echo request and echo reply packets, but inside of which non-standard information is transmitted. So you have yourself, on one hand, a router or firewall appliance that is allowing ICMP echo request and echo replies, which are used in traditional pings, for example, but then hiding non-ping style communications in plain sight or doing what is referred to as obfuscating. And then finishing up on some of our more common ICMP vulnerability options is going to be ICMP-based OS fingerprinting. The process of identifying what operating system is at an IP address and even what services are on that IP by probing the operating system, probing the services, and based upon their standard response, identifying, oh, this is a Windows-based operating system, or this is a BSD-flavored OS, or maybe this is Apache running on a BSD-flavored operating system. Our next slide here is continuing to review some ICMP vulnerabilities with what is referred to as an ICMP flood attack. Before we even move forward, understand that ICMP, as we mentioned a moment ago, let's remember, has many, many different protocol types or protocol options. So one of them they're showing you here is actually going to be based upon two different ICMP message types, an echo request and an echo reply, once again used by ping. Well, what we could do is have the attacker do a whole series of ICMP echo requests from a spoofed or invalid address, an address that doesn't even exist. So now the victim on the right-hand side is trying to respond to the ICMP echo request with an echo reply, but not getting the final bidirectional communication. So again, the victim on the right is consuming CPU to process, memory to buffer, network, bandwidth to communicate, all with an attacker, a device that really is not even a valid machine. And then finishing up here with our ICMP vulnerabilities, continuing with the idea of a distributed denial of service that uses ICMP, a style of DOS attack, or really distributed denial of service, a DDoS attack, is one that has been around for a very, very long time. I remember this one first being executed, I believe, in '99, so many, many years ago, what was referred to as a Smurf attack, where an attacker would ping a victim, a destination address that was really a spoofed address, but using the broadcast address space. So now any type of response is going to be amplified because, again, of using that broadcast address. And what I mean by any kind of response or any kind of communication is the denial of service, really now a distributed denial of service, is going to be amplified because the attacker was using that broadcast address.